We just invented a quick extension. Semi-stateful. Yeah. It's a real problem. I actually
what time is it? This is really sucky. I prefer it when it's good. So before we get started, is there anybody that's feeling like they want to take notes to prove that they're better than AI? Any AI doubters? Really want to stick it to Gemini? Come on. Anybody?
So as somebody who ran the experiment in Scone as to whether the local note taker could stick it to Gemini, it was like Ted's notes were slightly better, but only very slightly. And I'm also not sure how comfortable I am sticking it to Gemini in public. That's going to be in the minutes, isn't it?
I think you should re-ask the question with sticking it to Rocco's basilisk instead of Gemini and see if you get the same answer.
So just saying more seriously, our experience with the Gemini notes is they're actually pretty good.
Okay. But you do work for Google, so. Okay, so despite what the date says, this is actually November 6th, but this is the Ietf 124 quick working group meeting. If you didn't intend to be here, you can stick around anyway. Always happy to have you. But if you are sticking around, please open up the on-site tool to register your participation. It does actually matter for planning purposes. So yes, it is in fact Thursday, but this is still important. The note well is changed this year, this Ietf. So if you have not made yourself familiar with it, please do so. So again, we're going to quickly talk about some tips. It's pretty normal stuff, but like I said, please use the on-site tool or the full tool to add yourself to the queue as needed. We will be calling the queue and locking the queue. Please pay attention to when we lock the queue. It's real. And if you are either an on-site or an off-site participant, please keep yourself muted when you are not speaking. Oops. Whoa, that was weird. I lost my slides. Let's try that again. This is just, you know this by now. So admin, we already had the discussion about the note takers. Apparently we're going full AI on this, so we'll see how that goes. The chat is normal. We'll manage the queue, like I said. And you know what? Pass it over to Lucas to actually talk about other working group specific things.
Yep, thanks for that. Just to give quick updates on the working group, not terrible amount to report. Our recharter was complete. So if you recall, we had some discussion on this a little while back and then ran it past the IESG. So we now have a fourth work area, and we'll be discussing this again in a bit more detail in the quick stream multiplexing part of the agenda to come up in a bit. But that we got a gold star from Gori in the WIT area meeting, in case you weren't there. So we were very proud of that. And although it's our names there, it is a accomplishment for all of the Quic working group. So thank you all for that enlightening discussion and wordsmithing.
And just a quick note, I refuse to let AI take my job here, so I'll do note taking.
Thank you, Marco. We have some of the working group drafts on the agenda. We have some others that are just, making slow progress or sitting there for this time round. And we just wanted to highlight these three that are in a state of effectively waiting for either me or Matt to do the Shepherd's write-up. So in case you're curious, we've passed the working group last call on these three documents. We've been waiting for some implementation experience. And we believe we're at the state now where we have confidence to make the Shepherd's write-up and pass this off to our AD. We do have a lot of documents in this working group, kind of in this succeeded working group, but stuck not making much progress, and we really want to start draining that down. So yeah, thanks for everyone who's contributed to them, and we'll see how we get on with those. And onto the agenda itself proper, we're going to cover Qlog. I'll be speaking to that one. Then we'll have some time for the ACK receive timestamps. Then we'll move on to a chunk of time to talk about the potential solution for the quick stream multiplexing work item I mentioned, because we're chartered to adopt the document there. And in other our other bracket, we have some time to discuss a proposal for a new server preferred address extension and an extension for exchanging congestion control data. In terms of bashing, Lars might come and speak a little bit about a side meeting that he had. I don't know if you want to do that at the end of the whole session. We'll see how we do for the balance of time. And beyond that, does anyone else want to bash on this agenda? I'm not seeing any movement, so that's good. We can crack on with it. Take that one. I'll go up there. That's okay. I'll do verbal clicking. So this is the Qlog draft. I'm presenting on behalf of my co-authors, Robin, Luca, and Martin. Next slide, please. Since the last IETF, we had a special interim. So typically, we try and have an editor's call and hash things out between the editors that could make it. We decided it might be, because we've been blocked on a few items, decided it'd be maybe helpful to hold an interim and invite some other people. And it's incredibly useful. So thanks for the people that made the time there. We were able to kind of close out some issues that have been lingering for a couple of years. Based on that, we published a new set of drafts. We have 10 remaining open issues, 3 PRs, but they're kind of trivial editorial stuff like that as editors we would like to improve. So we don't want to waste the working group's time with that. Obviously, if you want to read the documents, give us feedback, that's excellent. But in terms of where we need help or kind of risk we foresee with these documents, there's only really 2. One is new, so I want to talk about that this time around, and one is old, from about the serialization format, which I'll touch on, but yeah, don't worry too much. But first, the exciting stuff is a revisit of tooling. We believe in running code at the IETF, and it's a big part of things. The drafts have been ticking along, but we've kind of been stuck in this state of implementations that generate some Qlogs, but not much, say, innovation in the space of the parsing tools or people wanting to pick up some of the latest drafts because they're stuck on tools being stuck. So I've talked about it on and off over the years in various places, but we finally open sourced some of the internal tooling that I've been having in my day job. It's a lot of code. It's not been merged yet, but it's open. So if you wanted to check this out and play with it, there's some README that's pretty bad. The documentation isn't great. I'd love to land this and get some more eyeballs and new ideas on these kinds of things, even just discuss it with people. So this is good from my perspective. It's another consumer. We've got a lot of producers of Qlogs, but we had not many consumers. But in better news, QViz is finally getting an update. So Robin's been kind of nose to the grindstone here, picking through a long set of feature requests and legacy tech debt, say. I don't know if Robin wants to speak more directly to what he's been working on, but you can follow along on the progress on his GitHub there. And then, as it says down at the bottom of the screen, there's a plan to deprecate support for earlier Qlogs. As always, holding on to support legacy formats is a big drain on time and maintenance costs. So we don't want to break people outright because it does take time to migrate. So I suspect the deprecation will last a while, but I'll leave that specifics for QViz up to Robin to elaborate on if he wants to in the chat or whatever. Next slide, please. And just second, an update, if all you do is come to the Quic working group, we are seeing some Qlog definitions and use outside this working group. So in TSVWG, we had the careful resume extension itself, but then another document that's been adopted for an extension schema to Qlog. Over in MOQ land, Media over Quic, there was a discussion earlier today about events for the mock transport protocol. So seeing some uptake of various implementers of MOQ to help address testing and debugging all the kinds of stuff we went through in the earlier days of Quic interop. And we're going to see if that venue is a suitable place for adoption. And we have Mathis over in AVT core kind of working on RTP over Quic and defining events there. Some hallway conversations I've had this week have expressed potential interest in doing this for other working groups like SCOAN or HTTP. And then really I'm bringing this to the room because I want to highlight the importance of completing the core documents such that we're not blocking other folks' efforts in this space. Which leads me on to the kind of the efforts in this space. During, well, no, let's tell the story here. So 2022, we had a discussion on scoping of the Qlog documents. Quic is evolving, it's a great platform for developing new things, and it's seeing success within the space of adopting the Qlog documents. Even to that point in time, there was, say, the core HTTP3 specification and the core RFC 9000 documents, but we had the datagram extension, the grease bit, all the other stuff that's listed here. And we wanted to avoid falling into the trap of delaying the Qlog documents by this ever-emerging pipeline of extensions. We had a discussion, but at that point in time, the line was drawn by anything at the end of the year that had gone through the kind of RFC IANA registration process would be in scope. And we punt on the other things to avoid us getting dragged out. But 3 years later, it's been a while. There's a few things that have happened that are used or useful to other working groups, such as web transport. We've got the Reset Streamat, Reset Streamat extension. We've got a few other things mentioned at the bottom. And one of the things, the opportunities we have is a minimal kind of update. Some of the open PRs, that we've got, it's not that much addition to the schema to define how you could express a reset stream or stream reset at frame. And what that would mean is potentially minimize a lot of work in creating a whole new document that is effectively half a page worth of useful stuff and a load of boilerplate and having to run that through the process, etc. So the question we really have is, you can go to the next one. Do we think that we can revisit that decision from 2022, given it's 3 years later? And if we do, can we avoid opening a can of worms to consider everything that's happened since then and really focus on some of the things that are quick wins, effectively? What's the low-hanging fruit here? What is so large that it would extend over a page and therefore we should punt on it? That level of gauging here. So 2 of the PRs I mentioned, the capsules and stream reset at, both feed into the web transport work that's going on, and then meter over Quic 2. And like I say, if this is something we even want to do at this stage, where do we draw that line? Managing multiple paths, as we decided to call this multi-path oriented document, that's now going to pass working group last call and is going to go onwards towards publication. It's potentially a lot of work to get the Q log for that correct. And that's something the editors, we haven't demonstrated an ability to do that in a timely fashion. And we need help to do those things. I'm not quite sure that we would be able to. There's a few people in the queue. Let's start going through.
Lars Eckert Musa. So I would make a more radical proposal that says don't do any of this, publish it now. And if anybody wants extensions, they need to write something new because we need to get something out. If you keep adding things to it, it's never going to get done. And this is not your fault, right? This is simply the way it is. I think like put a pin in it, like do the minimum number of things that you need to ship it out as an RFC. And then people know that this is the plan and they can plan their extension/BIS documents accordingly.
Okay, yeah, thanks for the feedback. Christian? We can't hear you if you're talking. We could not hear you.
Can you hear me now?
Yes.
Okay. The mysteries of little buttons that you don't know exist. I did the work of extending Qlog for supporting multipass for my own needs. And I'll be willing to work on you on that. The work itself, there's some part which is completely straightforward, which is to say, if a new frame has to be supported, format that new frame, print the pass ID where it needs to be, etc. Or print the pass ID in the header. This is completely straightforward. We could do it now. It could take a week or 2 minutes maximum. The part that is not straightforward is updating the tools to understand that there are multiple number spaces. And if you look at, if I feed what I produce into QVis right now, it's a complete mess because, I mean, packet number 1 in ACSpace number 5 is matched to ACK number 1 in ACSpace number 7, and you have lines crisscrossing each other. It's a complete mess. So the definition of the packet is something we should start with, and it's not hard. If that can be done as an extension, I'm willing to do the work on the extension, but I don't understand exactly how one specifies the extension to your document.
Okay, that's a good question. We did spend a significant amount of effort and time on our extensibility story. And that's kind of why I wanted to mention it earlier on, that we believe that maybe it's not clear in the documents and we can improve on that, or I can explain it offline, but we believe that the extensibility story is strong enough to allow for us to have these separate drafts and that they will compose correctly and work.
So basically, I'm willing to do the work, but I need to have someone helping me on making sure the extensions are right.
Yeah. Okay. But that doesn't answer the question of if that work should be done as an expansion of the scope of the Qlog documents. Are you saying you would want that to happen, or that you could live without and just as a completely standalone document?
It's a matter of time. If basically, as long as we don't change the, we know in fact that the frame numbers and things like that are going to change when we publish. So, so we have what maps to say multipass acknowledgement will differ after we publish. So it might be okay to say, okay, wait until we publish, we have the right numbers, we can map them, it's okay. Okay. So I'd be fine to do that as an extension after the multipass extension has been actually published, or at least approved is in the RFC queue. but I need help, that's all.
Okay. Yeah, for the balance of time, I think we can progress through the queue, but no, that's good information, Christian. I expect we can follow up on the list or online with you. Thank you.
Okay.
Who's next? Corey. Oh,
Martin
Martin.
Seemann, Small Step. I want to address what Lars said. I agree that we should get the document out as soon as possible. I don't think that these two issues are what's blocking us from publishing the document. There are some more thorny issues that we need to work through, and some of them are my responsibility as an editor of this document, and I'm planning to work on these. I think that the line in the sand is like, it sounds reasonable to me that we say like, okay, if something is really just a few lines of code, like reset streamat, then let's do it, as long as it doesn't delay publication of the document. I don't think that the multipath or managing multiple path document meets that bar, so that should go in a separate document.
Okay. Thank you.
Hi, Gary Fairhurst, just with a question. You put other drafts up apart from this one, well, a series of them. They're presumably extensions that would be okay if this goes ahead now? In other words, do we have a framework which is good enough that we can ship and then do extensions after?
We believe the framework is suitable. Obviously, the more people that write extensions and exercise the framework give us good feedback, such as yourself earlier in the process, Gary.
Yeah.
My concern is that the framework also relies on things like IANA registries to be set up. The longer we delay, the longer that those documents will end up stuck in an RFC editor queue in a humongous cluster of stuff. And they're very unrelated documents with each other. And that's frustrating if you're stuck like that. So.
Yeah, I was feeling that frustration. I was thinking that why don't we just ship, as in ship this, and then we open another document straight away to do whatever we want to if we need to. It seems okay.
Yep, and that's kind of along the lines of something we discussed. We don't need a document which is each individual item. It could just be here's 2005's greatest hits, whatever. Because the extensibility model is not RFC numbers, and thanks to the folks who pushed us away from that direction a couple of years ago, they are namespaced with identification of what they are. So, yeah. But to Martin's point, these PRs are there and they're pretty much ready to just emerge. They're not going to delay anything from the editor's perspective, at least mine personal perspective as an individual and Martin's. I would encourage people to take a look, and maybe we can take a decision to the list and just see and get some feedback that way.
Maybe we could take a deadline and just say, if we've managed to do this by then, we're okay. If we haven't, then we will working group last call. Just a suggestion.
I mean, so, as editors, well, some of us would be happy to merge these. The issue we've got is it breaks the rule that we made for ourselves a few years ago. And would anyone be opposed to us breaking or bending that rule? Lars?
Lars, again, if you hadn't mentioned the rule, would have anybody remembered that you had that rule? And I think the answer is no, so just do it.
Okay, no, I think that's good input. Yeah, the editors can take this away. Very clear from my perspective. Obviously, we'll confirm by GitHub and the list on this. All right, cool, let's move on. And then, yeah, the other potential blocker is this JSON streaming sec thing. This presentation from 2 years ago that there's no new information here. We have an opinion on formats and streaming. What I'm going to just put a call out there is if this is something you feel strongly about or have some good knowledge of, we've tried to do some kind of back channeling in the meantime and refresh people's memories, and it's like there's not really anything there. So speak now, but not at the mic, not right now, but like come and speak to me or Martin or somebody. It might just be that we live with what we have now. The easiest path to publishing the documents as fast as possible is to keep the text that we've got there. But if there's strong opinions about not doing that, this is the kind of input we need. Cool, I think. And yeah, we would love to do a working group last call before the next Ietf meeting, but we've been saying that for 2 years. So, believe me or don't believe me, whatever. Cool. That's it. Who's up next? Yes.
Okay, so the next presentation is, oh, sure, thank you. This is the Quic packet receive timestamps draft. Ian, Sweat, and myself are the editors for this draft. Just a quick refresher about the draft. It's to enable the peer to report packet receive timestamps for some or all ACT packets. The timestamp is connection local and not intended to be absolute. These new additional fields are added at the end of the existing ACT frame. Since the last IETF, this draft has been adopted. We're now at 0.0. We trimmed the editor author list, very minor editorial changes. We don't have any open PRs, so if you haven't read the draft, it's pretty short. Please read it and open issues or PRs. I'll go through the open issues quickly. Some of them are bigger than others. This is probably the biggest one. The issue is to make this extension independent from the ACK frame. The reasoning for that is timestamps should be independent of the ACKs, and it makes it easier to extend. However, the editor's view there is that timestamps are actually closely tied to the ACKs, just like ECN counts. Separating them would introduce unnecessary implementation complexity, and we do have a couple of existing use cases that expect the data to be available with the ACKs. For example, we have at least two implementations, the Google Congestion Controller and SQP CCA, which was published by the original author of this draft. It expects the data to be available when the packets are ACKed. And on the extensibility aspect, our view is that we can define how this coexists with our other extensions in simple ways. It's actually not that complicated. So any thoughts, comments about this issue? Great. I guess the editor's view sounds good. Okay. So following up on that last point about extensibility, decide how multiple ACK frames extensions can coexist. Right now we have the text, the last couple of sentences say the extensions are going to be ordered in RFC number. We discussed this last IETF. We decided we're going to drop that last sentence about the RFC number. Timestamps go at the end of the frame, and future extensions can specify more elaborate coexistence mechanisms if needed. So we will make that update in an upcoming PR. Any comments, questions on this one?
Lars Eckert, I think you will need to update the base Quic spec here because you're changing how the ACK frame is maintained going forward. I don't think this is an objection. It's just an update, this thing, because people will need to read this new document to understand what's in the ACK frame.
Sure, but this is negotiated separately. If we don't have the transport parameter for the extension, you wouldn't see that in a normal Quic connection.
Okay.
So I'm not sure we need an update.
Correct. Maybe I didn't fully think this through. The other thing is there a reason why you always append? Do you need to say this now, or could you leave it up to the future extension to decide whether they want to be prepend, for example?
Yes, correct. Yeah, we don't have. It doesn't have to be append. Yeah.
Sorry, Antonio. Can you go back to the structure of the frame that you're actually proposing?
Yeah.
I mean, my possible worry is that if you actually were to put something in there that's not those timestamps, I guess you have to actually put at least the count B0 and then put the other thing behind it. in some ways, like the current structure can tell you like how long the part actually is, and then maybe you have some other things afterwards.
Sorry, can you repeat that last sentence again?
It seems that like the timestamps are like fixed size.
Yes.
You have a count, so you know how many bytes are actually timestamps. You could actually have a second extension after that.
Mhm.
But you might still be stuck to always have a 0 in there, or like some other type field that says this next thing is timestamps, then something else is afterwards.
Yeah, so that's the coexistence part that we would leave for a future extension. Like the argument is that this one is going to be at the end after like the existing packets, including maybe ECN, depending on the frame type. And then after that, if you've negotiated the extension, you would add this at the end. So we know when it starts after everything else, it will end with the count, and then the coexistence is left to the next extension. If someone wants to go after this, and this is not present, they will have to figure out or specify how this will happen.
Okay, thank you for the clarification.
Sure. Okay, the other two open issues. Sorry.
So as you mentioned multipass here, multipass is done, right? So multipass will not specify an extension that uses timestamps. Are you planning to now define an extension that uses multipass X with timestamps, or are you expecting somebody else just to write another extension to do that?
So the argument would be if this is negotiated and multipath is negotiated, this will go in the end. After the multipath fields, and this will be in the end.
So you just edit, you don't even specify it.
I'm sorry?
You just say it's automatically added. That's
Yes.
what you say in your
Yeah,
draft.
we
right?
can add the text to make it more explicit if that helps.
Okay, but you're planning to put this into your draft.
Yes. Yeah.
Thanks.
I mean, there is already a reference for the multipath in the text.
I just wanted to know.
Yeah.
I do have a bit of an opinion here. I mean, the argument that ECN is in the same egg is not a good one. Maybe we should have decided differently in the past and didn't think this through, right? So I don't buy that, but whatever.
Okay. Oh, Christian?
Yeah, what you are proposing is a bit dangerous because the way we have done extension of arcs in the past is by changing the frame number, the frame type. So what you're proposing to do is have the same frame type parsed differently depending of whether the transport parameters have been negotiated or not.
Yes.
And that's a big change. I mean, if we had that, I mean, that kind of negotiation, we should say, okay, if multipass is negotiated, then we don't need to have new ACK frame types. We just use the existing frame types, but because multipass negotiated, now you know that you will have a pass ID in position 2 and things of that nature. We have not done that because it makes parsing somewhat difficult. And so I think that the point that Lars was making, you are effectively changing the base Quic specification in doing that. And that's a big thing to swallow. I understand it's one way to not get the explosion of we need a combinatorial explosion of frame types, but that's a big change. That's a huge change.
Yeah, the alternative of the explosion of the ACK frame types is also one that I think would require some kind of separate specification. I think we discussed that a couple of IETFs ago, if I remember correctly, because like which extension is going to specify the new combinations of frame types? Is it the one that comes later?
No, the one we have done so far is if you have a different format, you have a different frame type. And if I receive something with a frame type, I can always map that frame type directly to a parser. What you are saying is that, yeah, I can map that to a parser, but that parser has to be cognizant of whatever negotiation has happened so far because the parsing then changes. And that's kind of fragile.
I see. Yeah, thanks for the input. Other opinions or feedback?
Right, so Kazuho, so I actually think that the current approach of reusing the same ID and changing the format is correct because first of all, we avoid the combinational explosion of frame IDs. I mean, for X, we typically want to use a short ID, but for example, multipath is going to use another two. What number are we going to assign for it? And then if we choose a different ID for this one, then we use another two. And then for the combination of this one and multipath, we use another two. And so in addition to all the registration process, there's the potential of running out of short frame IDs. And so I kind of think that if we have to converge on one approach, I think this one is the correct one rather than the precedence that we have in multipath.
Yeah, I was actually assuming you would define new frame types, and I strongly recommend this because, I mean, yes, it's somehow an explosion, but frame types are cheap, so I'm not sure what problem we're trying to solve by not using new frame types. I think we make parsing and everything just more complicated. Also, it would be consistent with the use of accurate ECN, not accurate ECN, sorry, different protocol, with ECK frames and ECN because they also have a new frame type. So like just changing this in the middle of the protocol seems weird to me.
I agree with Christian. Please use a new frame type. And as a point of reference, the reset stream extension added a new size field to the reset stream frame, and we're using a new frame type there as well.
So just a follow-up question. In the case of multipath, then, do you expect this draft to define how it would coexist with multipath with two additional frame types, or would you expect multipath to do that? Because I think this is one example of what would happen.
I guess that depends which order the documents are published in, and it looks like multipath is getting published first, so that would be the responsibility of your document.
And would you require like future extensions to define additional frame types for every existing extension?
That depends on the extension. I mean, you could say, I don't care about multipath, and you can't use this extension with multipath, and that's a decision that you can take.
Christian?
I see. I mean, there is merit in having this combinatorial, avoiding the combinatorial explosion. But basically, that's for me something for the next version of Quic. Okay, we can define the next version of Quic in which we specify that we avoid combinatorial explosion when extending frame types by having this kind of process. But we cannot define that in Quic v1. That's not how Quic v1 is done. We have to live with the combinatorial explosion. Now, it's an explosion, but let's say it's going to be a number like 8 or 16. We are not speaking 5 million. So I think that we have, as long as we have Quic v1, we have to basically accept that there is a combinatorial explosion and have one frame type maps to exactly one frame format.
I don't think we're stuck with doing this only for V1, because one of the intermediate proposals that we reverted based upon feedback from the group previously was to have a transport parameter that would be the bitwise indicate which extensions are in use. And the feedback we received was, this is an overkill. We don't have that many extensions we expect to be there, so we should not have that. And we ended up reverting it.
Just use different frame types. Just use different frame types for now, because that's completely in line with Quic v1. It doesn't mess up everybody's parser. That's basically we should do that. It's less elegant, but it's actually more robust.
Sure. I mean, I see the argument, but on the counter argument, I think most stacks currently have a single parser for these two types, and you just treat ECN as optional. So I think in practice, people are not actually parsing these as two separate frames with ECN or without.
That is not true for multipass. Your parsing code does change because the sequence numbers are in a different space.
Lars, I was going to make a similar argument to Christian, but the other way around. So I agree with Kazuo, and I agree with what the draft currently says, but also Quic version numbers are cheap. And if we maneuver ourselves into a situation where we find we made a wrong architectural choice here, we spin a new version and we refactor how we do acts, right? I mean, this is the nice thing about Quic, that we actually early on decided we're going to have a lot of flexibility to unstuck ourselves that we could never do in TCP, right? So we don't have to get this perfect. We just have to pick a reasonable choice now, because if we get it wrong, do a new version. It's good, grease it.
Alessandro Ghedini, Cloudflare. I'm not sure if this is an entirely stupid idea, and it might make everyone sad, but you said you don't want to have timestamp as its own frame because you want it as part of the ACK processing, right? But couldn't you just say you have the timestamp frame that has to follow the ACK frame, and then in your parser you could just treat them as a single frame?
What if they don't arrive in the same packet? What if you lose one?
They would have to be in the same packet. The same way you encode timestamps now, you have an ACK frame and a timestamp frame, and they have to be there together. And then you gain the framing for the timestamp, so then potentially you can have other ACK extensions, and then you can still treat them as a sort of single frame in your processing. But again, I haven't implemented this, so I don't know if it's like a stupid idea.
I mean, my impression is if it's two frames that I'm treating as one frame, then they should be one frame.
Right, but then you need multipath with timestamp and without multipath and timestamp, and it feels like having its own frame makes the whole extensionability of ACK frames a bit easier to do without having to define like a million frames.
Antonio, I was coming here to say a very similar thing. You have some convention that you usually have one in front of the other, and these things can be ignored if you don't actually understand them. But yeah, it's actually somewhat inconvenient to actually have some convention that requires certain frames to follow each other in the same packet. It's the only way that actually makes sense.
Look, I mean, I actually have experience with having the frame separate. I did that for the first version of the timestamp that was tried a couple of years ago. It does work, but the semantic is different. If the frame is separate, what you timestamp is the packet, not the acknowledgement. So basically, that gives you some value because, for example, you can know when something is sent, etc. But that's a different solution. Given what I know has to be done if frames are separate, I don't think that's the best idea, based on experience.
Alessandro Ghedini, Cloudflare. I think my idea is specifically, if you negotiate the timestamp extension, then whenever you put an ACK in a packet, you also put the timestamp frame immediately after it. So they would still be sort of coupled together.
That's also what I tried. That's exactly what I tried. Okay, and the problem is that the problem comes, for example, with retransmission. You can have to retransmit a packet, and your MTU has changed, and you cannot send the two frames in the same packet anymore. That's one example. And also, the other problem is that nowhere in Quic do we specify that frames in a packet have to be specified as we parse in order. Nowhere. And so that too will be a change with potential incompatibilities. So, I mean, no. I mean, I understand that we have a difference of opinion on the best way to either avoid combinatorial explosion or guarantee that a frame type parses exactly one way. I mean, this is a clear difference of opinion, but it can be, in both cases, it works. I mean, the worst case we have in the combinatorial explosion is that we double the number of frame types. Currently, there are 4, we'll get 8. That's not good, but that's not completely bad either. I mean, we can deal with that. Or we could even simplify by saying that if you have to have timestamp, you must have ECN. That would be also one way to solve it. To not have the explosion, just have something linear instead of exponential. I am not happy with the idea of having the same packet type parsed differently, unless we change the quick version. If we do change a quick version, as Lars said, then I'm fine. But I mean, it's really a question of quick version there, saying that, okay, we do this, we have quick version dependent parsing, that's fine. But otherwise, no.
Kazuhoku, so I'd point out that we probably don't need to take how we retransmit frames into consideration, because Quic is supposed to retransmit information, not frames. And then I actually like what Alessandro proposed, because it's easy to implement. I mean, for example, he's already talked about the encoding side, but for the decoding side, what you do is you decode all the ACK frame as is, and then check the next byte speculatively. And then if it's this ID, then it's a continuation of the ACK frame, so you can pass it. So it's very easy to pass, and we do that kind of speculative decoding anyway, because frames are self-delimited. So it actually follows the model that we have already.
Lars, I got Mozilla, so similarly inspired by Alessandro and Kazuo. So if you negotiate this extension, what if you only get timestamp frames, and the timestamp frames at the end embed whatever current ACK frame you want to send?
So
and
it's
that means
the opposite.
It's the opposite, but it follows, right? So it's not you don't concatenate two frames. One frame embeds the other, which means you parse the timestamp frame, and then you parse the embedded ACK frame. And the bytes are the same, but the logic is different.
Martin to Google, I think all the the Baroque solutions just create weird edge cases, and I don't want to do that. I think there's two basic proposals, which is basically the two ones that Joseph presented. I'm not at all convinced there's a real substantive impact on performance, on implementation complexity. There's just sort of like a stack preference, and we seem split. So I suggest I think this is a bike shed, and I think we should flip a coin and move on.
Ted Hardy, as author of Alternative Decision-Making Drafts, this isn't one you would use it for, because there really is a design question here. And the design question is, we have part of the working group that has asserted, and I think correctly, that right now you determine whether there are differential parsing strategies by either using a different frame type or using a different version. This draft uses a transport parameter negotiation to change that, which is different. And the working group can decide that that's something that they'll now permit, but I don't think it's a flip a coin question, because it introduces a new way to determine whether or not you're going to have differential parsing. And I think that's a design decision, not a flip a coin decision, as much as I like the occasional foray into alternative decision making.
Yeah, I agree. It's a design decision, and we should make it well thought instead of having the discussion every time we do another extension again. I'm very worried about kind of changing a frame type using transport parameter negotiation, because it's not a negotiation, it's a declaration. I'm not sure that will work in all cases.
Okay, we'll take this conversation back, and the editors will discuss it again. The last two open issues are just general advice about best practices for writing the timestamps. One of them is about emphasizing that timestamps are best effort within the ACK or in a separate frame, however we decide to do it. And it should not result in writing a whole new packet. And the other one is, if we can't report all timestamps, should we prefer the latest received or the highest packet numbers. So this is one of the other two questions that we could use some feedback on.
Lars, like at Mozilla, can you say a bit more about this issue 14? Right, because if I'm writing frames into a packet, I have a choice of how I order them and what I prioritize. So are you saying I should prioritize them higher or lower than the stream frames or X or
oh,
like,
so the extension defines how many timestamps the maximum timestamps
Right.
the peer is willing to accept. So it's either that could be your limit or it could be the size of the packet.
right?
We
But
don't
I have,
want.
I have a choice when I start writing the frame.
Yes.
Right. If so I don't understand what this gets me, because I still need to decide, like, do I write this frame first when I start writing the packet, or do I do it last? It seems you think I should write this at lowest priority, and that's how I might
Yes.
end up in a case where
Yeah, we're assuming that like you put all of your ACK, then whatever you're going to put in the ACK, and then the extra space in the packet you're going to fill with timestamps up to the maximum allowed by the peer, up to the maximum number of timestamps allowed by the peer. And when you have more than that, what do? Do you drop the most recent ones? Like, do you start with the most recent ones, or you start with the highest packet number?
I think you have an implicit assumption about how frames are being laid out in here somewhere, but I need to read the ticket again.
Christian?
I think that is, I mean, if you pull that thread further, you get into the ACK frequency draft.
Sorry, I missed that.
Well,
I couldn't hear you very well.
Christian, I think your mic got moved.
Shit.
We can hear you, just it was very soft.
Okay. I'll put the mic there. I'm sorry. No, look, there is an interaction between what you said and the ACK frequency draft.
Yes.
Okay, because the ACK frequency draft can say, for example, I just want 4 ACKs per RTT. And if I am sending 10,000 packets per RTT, that means that I'll be acknowledging and practice 3,000 packets for each RTT. No way I'm going to get 3,000 timestamps in a packet. Okay, so that means that you have to have a strategy. And if we think of that strategy is very similar to the kind of strategy that we have when we're making decisions about sending ACKs in the ACK frequency draft. So if you have to specify the strategy, I would think that we should specify that in conjunction with the ACK frequency draft.
Yeah, that's fair.
And the ACK frequency draft has this notion that your ACK is triggered by something. It can be triggered by just you have received more frames, or it's triggered by you have just filled a hole. And those two, these are the main two, okay? And these main two means that if I am filling a hole, and that's what caused me to send an ACK, then probably I need to have a timestamp for that hole filling packet. Because I will want to know, use the timestamps to find out what's the parameters of packet reordering and things like that. If, on the contrary, I'm doing that because I've still received more ACKs all in sequence, then it doesn't matter. I can just send the last receive. But we have to consider those two are actually quite intertwined, and we have to say something about it.
Yeah, sounds good. Okay, that's all there is another issue open about security considerations. The only one we can think of is just ensure that if your congestion controller is going to use this, the peer can manipulate it and make sure that you don't produce unrealistic bandwidth estimations based upon the timestamps. And we don't have other ideas for security considerations. If you can think of any, please share them. Yeah, that's it. We will continue the discussion MoveFast has an implementation of some variant of the current draft. Quiche has an implementation of the individual 0.1 draft. We can try to do some interop if you have an implementation and you want to try it out. Other than that, thank you.
Kazuha?
Hello. So just before Kazuho starts, I wanted to kind of bookend the presentation. I touched on this during the kind of chair slides here. We recently recharted. In the interest of progress, we would really like to get a document adopted into this working group. Last time round, we had a presentation about some of the kind of protocol wire format stuff that could be, optionals here. Kazuho is going to focus today on a proposal that picks one of those that could be a starting point to iterate on the technical design. I'll try to encourage anyone else who might have some ideas to post on the list or anything, but I haven't personally seen any of that. So, Kazuho, take it away here, but consider this document with, listen and absorb with the intention of, is this something you would consider is a suitable starting point for adoption into this working group? And we'll take some show of hands at the end of the presentation and the time slot to help us gauge the interest. Cool, thank you.
Thank you. So let's start. So as Lucas said, we've updated the charter. Thank you to the chairs, ADs, everybody. And now we say that the fourth area of the work is to specify how quick stream multiplexing and other application-oriented extensions such as datagrams can be adopted. And we also say that the substrate is going to be TLS, and it could be something in clear text, but we wouldn't spend energy in, making the clear text use case better. And so let's go back to what we presented at the previous Ietf, comparing the potential approaches to do QMax. We discussed 4 approaches, which were web transport over H1. Basically, this is a modification of web transport over H2 that uses capsules. But because H2 is too complex and has unnecessary complexities, the idea was to use send capsules over web transport over H1 rather than H2. And then there's the other proposal to skip using H1 and just send the raw capsules. And then there's the third one, which was to send Quic version 1 frames directly on TLS or any bidirectional byte stream. And then there was the fourth one that would retain the current packet format but send them on the TCP connection. So, and we did compare the benefits and the downside, but obviously it depends on how you view it, or how you plan to implement it. Like, for example, if you are going to code from scratch, then probably the easiest ones are B and C, which is using capsules or VM frames. Whereas if you are going to code QMax on top of Quic VM stacks, obviously the easiest one is either using VM frames or VM frames and packets, because you can reuse the frame parser and encoder rather than writing a capsule encoder and parser. Or if you are to code QMax on top of web transport over H2 stacks, obviously the easiest one would be to use web transport over H1, because it's just about using a different HTTP version under the hood. Or like, from the perspective of specifying the protocol, probably the one that has the least uncertainty is also the web transport over H1 one, because it's just about doing it on H1, but otherwise other proposals might have other pitfalls as well. and we need to discuss. So that was the recap from the previous Ietf. And now I'm going to go to our proposal, which is this draft, which was formerly called Quic on Streams. Nobody liked the name, maybe except me. I'm sad. But anyways, let's go. So this is the V1 frames approach that we discussed. So to recap, this is the sad state that we are in now. Because we have Quic and TCP, each application protocol, for each application, we have to now develop 2 application protocols because the underlying substrate is different. And we cannot stop using TCP. If we could, then things become simple. But because there's things like UDP port blocking, or because Quic has unnecessary overhead when used on transports that provide reliability and protection, people care about, for example, data center performance, prefer not to use Quic because it's unnecessarily slow due to the fact that we've coupled encryption and retransmission and all things in one for good reasons for the internet, but not necessarily required for their deployments. So what we need is a unified interface. So what we could do is backport the Quic API contract, which is the interface that the application protocol uses to over to the TCP, TLS, or any bidirectional byte stream substrate, and then use that unified interface to implement a new protocol. For example, it could be anything like, for example, it could be MOC. But because UDP plus Quic or QMAX would provide the same programming interface, then things would become easier for the new application protocol developers to implement, new protocol designers to specify. So that's the goal of QMAX. And admittedly, it might be a bit too late for some application protocols, but I'll say that it's better late than never. We are seeing new wave of Quic-based application protocols being developed, so it's better to have a compatibility layer to cover TCP so that the application protocol designers and application developers can rely on one thing. So the goal of QMAX, as we see, is that it's about providing a unified interface to protocol designers and also application developers. And the reason I bring up application developers is because, in our view, the smaller the divergence of QMAX is from Quic version 1, then it becomes easier for the Quic stacks to add support for QMAX. And by doing so, we can maximize the chance of application developers seeing their Quic stack of choice support QMAX. Because, even if we unify the programming interface, the API, the interface being defined by the specification, each Quic stack has a different API. And for each application developer, there's the Quic stack of choice that they are depending on. So if they are to support TCP or QMAX as well, that Quic stack needs to support QMAX. Otherwise, the application developer has to support 2 Quic or QMAX stacks, and that creates a complexity for them. So we want to maximize the chance of every Quic stack potentially supporting QMAX, and that's one of the design goals that we have. So therefore, the approach is to retain Quic version as much as possible rather than trying to be clever. Like, for example, we intentionally avoid changing the stream state machinery, or we intentionally avoid changing the frame encodings because doing such things are going to make the porting work more complex, or it reduces the chance of existing Quic stack support QMAX. So we intentionally avoid that. And we also outsource the heavyweight functions to substrates. For example, loss detection and congestion control, as we know, it's being outsourced to the underlying substrate, but we also avoid packetization or encryption because that can be done in TLS. So by avoiding those, we reduce the overhead, and therefore we meet the goals, meet the requirements of the deployments that are currently unsatisfied with Quic version 1. So let's dive into the protocol overview. I'll go through these topics. First, negotiation. As the charter says, the Qmax is not supposed to provide any solution tailored for clear text communication. Therefore, the application protocol negotiation Qmax would rely on TLS for doing the negotiation of the application protocol. And then, but because we want to use existing Quic stacks, we need a way of exchanging the transport parameters. And for that purpose, we define a new frame called QX transport parameters frame, which carries the transport parameters. And regarding which transport parameters we allow transmitting, we ban the use of the transport parameters unrelated to data transfer. For example, like original source connection ID, it's banned, but otherwise, things like max transport parameters and those things are used as is. And there's also a new transport parameter, one new transport parameter called max frame size that communicates the maximum frame or maximum size of stream or datagram frames that omit the length field. Because in case of Quic, because there's the packet boundary, when these frames omit the length field, you could infer the length from the packet size. But Qmax is running on top of a byte stream, so we need to communicate somehow what the length is when the length field of these frames are omitted. And for what's worth, the default is set to 16 kilobyte because it's the default maximum of a TLS record. So the frame encoding, as said, is exactly the same as Quic version 1. And for each stream frames are always sent in order. And that means that there's no need for buffering or reassembly. And because we want to reduce the difference from Quic version 1, the offset field of stream frame is required, even though it's a redundancy. I mean, we can change this if necessary, but this is the design that we currently have. And so how do we decode the frames? Endpoints, because the frames are sent over a byte stream, endpoints need to be prepared for receiving partial frames. So what the receiver would do is, like, when receiving new data, call the Quic version 1 frame decoder, and then if the frame is truncated, retain that input. Because you know that it's a partial frame. And then as more bytes arrive, you repeat the process of speculative decoding until a complete frame is received. So that's typically how you implement Qmax, I'd assume. And the good thing is that there's no need for a dedicated logic to handle frame truncation because you already have the logic of detecting truncated frame in Quic version 1 decoders anyways, because it's a violation. So you can reuse that logic. And for what's as an optimization, receivers might stream the payload of stream frames. I mean, if you receive a partial stream frame, you can start streaming the payload to the application as the parts of the stream frame is received. But fortunately, there's little reason to do this because TLS provides data by each record. An application, protocols running on top of TLS cannot process bytes as they receive. They have to wait for the complete TLS record to arrive and then the TLS to do the decoding. Therefore, assuming that the sender fits the stream frame to the TLS record boundary, this kind of optimization is not required and would not typically be necessary. So that's one of the benefits of using this design. Antonio?
Hi, Antonio Vicente, Cloudflare. I think you need to actually decide if you are going to actually depend on just TCP semantics or TLS record boundaries as a way, something that is actually useful in your protocol. If you actually have an intermediary that is actually doing, say, TLS interception and repackaging, you're going to actually lose those TLS boundaries that you actually depend on so strongly. It will be simpler to not rely on that by just requiring data frames to always have a size.
Right, so we could rely on we could require the TLS stacks to provide the record boundary, but existing TLS stacks doesn't provide that. So our sense is that we should support any byte stream that doesn't provide the boundary. And that's why we define the max frame size transport parameter that communicates the maximum frame size when the length field of frames are omitted. So let's say that you receive a stream frame that doesn't have a length field. Then you know that the frame size is max frame size. So that's how it works. And of course, we don't have ACK, and ACK frames are explicitly prohibited because retransmission is the task of the substrate, and ACK frames is going to be an overhead if you have it. And as an implementation advice, when adding support for QMax, quick VN stacks can just pretend that the frames are ACK the moment they are written to the TCP socket. Because every quick stack assumes that it has to do the loss recovery, but the easiest way of skipping loss recovery is pretend that they are ACKed the moment that you send. So it's actually easy to implement. And for what's what, these are the permitted frames, padding, ping, and all the stream-related and datagram-related frames are allowed, while the ACKs or crypto or other connection management frames are prohibited. And for what's what, only the application level connection close frame is permitted, because the transport level frame is being used for communicating handshake errors, and that's the task of TLS in case of QMax. So let me explain how our implementation experience was. In case of Quickly, we wrote a proof of concept that works in half a day. And it took only another half day to integrate that into H2O and speak H3 over QMax. And in case of Quick Go, it only took one hackathon to implement QMax and do an interop with H2O. So for these two stacks, it was actually very easy to implement. And I think that's a good news. So this is how we did. In case of Quickly, on the sending side, we allocate buffer for building a quick packet, but the size is set to 16 kilobytes because now we are using QMax. So instead of allocating a buffer for a single packet, we allocate a buffer for a jumbo packet, or jumbo record. And then instead of generating the packet header, we just skip that logic and build frames as like you do in case of Quick version 1. And because we use the same logic, we register the ACK callbacks that would be called when those frames are ACK. But before sending these frames, we just run the ACK callbacks to pretend that they were ACK so that they would not be retransmitted. And then pass the generated frames to the substrate. So that's only what we did. That's the only thing that we did. And on the receiving side, we changed the frame decoders to return partial error when a given frame image is truncated. In our old code, it was returning a frame encoding error, but we changed the logic to return partial error when the frame is truncated. And then we also changed the Quick version 1 receive function, the original code that handled Quick version 1, to convert that partial error to frame encoding error, because if it's using Quick version 1, then it's a fatal error. But if it's QMax, then if we get a partial error from the decoder, we just retain the bytes, and as we receive new bytes, we reprocess the bytes being received. So this way, it was pretty easy to implement. So let's go to the discussion. I think we have four things to discuss, and one is like in overall is the draft heading in the right direction? And the second question is like, is it correct to send frames directly on a bidirectional byte stream, or like do we want to choose an alternative like sending quick packets over a byte stream? And the third question is like, do we want to minimize divergence from Quick version 1? Or like, do we want to do optimization like Web Transport does, like omit the offset field of stream frames or tighten the stream state machinery, because you can do it due to all the frames being sent in order. And then the fourth question is, about frame encoding. Do we want to do quick version 1 or capsules? Ted, is it a clarification question or is it a discussion?
I wanted to talk to the open question number 1.
Okay, so let me go through it because I'm covering the open questions. So our take for quick version, the first question, is the draft heading in the right direction? Is that, of course, we think it's the correct approach. It's a simple, and it meets the requirements of the updated charter. And, well, that's the reasons. And, oops, sorry. Yes, here it comes. So regarding the second question, should we send frames or capsules directly on the bidirectional byte stream? I think the answer is yes. And it's because packetization and encryption should be possible to offload to the substrate, because then we'd have the opportunity to use hardware flow, for example. I mean, QMax, one of the deployments of QMax is the high throughput data center scenarios, and we want to support that. And the third question, do we want to minimize divergence from quick version 1? Our answer is, of course, yes, because as said, diverging as cost to standardization, implementation, testing. And we want every quick stack to support QMax, as many quick stacks as possible to support QMax. So it makes sense to minimize the diversion. That's our view. And going to the last question, we think using quick V1 frames is better than using capsules, because there are far more quick stacks than web transport over H2. And because we want to see existing quick stacks support QMax rather than requiring the application developers that currently depend on the quick stack to also use a different web transport stack. And thirdly, because it's easier to manage the frame encoding and registry inside the quick working group rather than figuring out how to communicate with the HTTP working group to manage those things. So these were the 4 questions, and now I'd like to ask what Ted has.
Ted Hardy, thank you very much for the presentation and for the enthusiasm. I have a concern here that I think is either in Q1 or possibly in a question you didn't ask, and that's about ossification. I understand that you want to present a common API, whether or not UDP is available, and so whether or not you're sitting on a substrate of Quic V1 over UDP or TLS over TCP. But it looks to me like the way you're doing it, in particular about how you're ruling out certain kinds of negotiation, is going to result in ossifying Quic, because Quic MUX as the common API will ossify Quic as to the thing that's the minor variant of Quic V1 that it supports. And I kind of question whether we have enough data at this point to say that we're ready to ossify Quic, because Quic itself was, a very large set of design choices that we're trying to avoid the ossification that had come with TCP, and that by re-importing that, we're going to have TCP as one of the substrates again with TLS on top of it, and tie that into this common API. I'm quite concerned that we don't have a strategy for avoiding ossification here if this becomes the common API to applications. So I would really appreciate you and the other authors of this thinking about what does it take to move this from Quic V1 to any of the other versions of Quic, given that we previously said in our discussion over the ACT framing, versions are cheap. But versions are cheap because you can negotiate all kinds of things that this looks like it rules out. And so I really appreciate you sharing your thoughts on that. Thank you.
Thank you. I think that's an excellent point. And maybe my response is that there are 3 aspects of ossification. One is ossification caused by network elements. I mean, TCP has this problem of mailboxes expecting particular behavior, and but in case of QMax, the API being talked is the interface between the Quic stack and the application. So we don't have that aspect of ossification concern. And secondly, it's about the internals of the Quic protocol, that how it transmits the stream state and those things. So, and that's also different from what QMax does, because QMax is about the interface above it. So I do agree that the interface is, well, by using the common interface with Quic version 1 Qmax, we are going to, probably, converge on one application interface, and that could be considered ossification. But to me, it seems that the generic, the API contract that we have for streams and datagrams are well thought enough, and we find similar patterns in things like SCTP. So probably that's okay. That'd be my
So
take.
I'm going to disagree with that. And I'm going to point you to mock as an example. Right? If this had existed so that there'd been this convergence prior to MOQ being developed, MOQ's vision of how you do media over Quic would not have worked, because you definitely cannot do that over TLS over TCP because of the way that underlying substrate will interact with the requirements of the media. So had this happened before MOQ was developed, MOQ would not have developed on top of Quic. It would have, because Qmux would have sort of ossified the API into Quic in a way that would have prevented it from succeeding. So I think we've got to be very careful about this to figure what class of applications can effectively use this, and what the ossification results will be for the set of applications for whom the distinction between Quic over UDP and TLS over TCP is quite significant. So thanks again for your thoughts.
Thank you very much. I don't understand mock very well, so I cannot make comments based on what they think. But I'd argue that web transport over H2, that mock depends on, has the exact same problems as Qmux has. So if they are okay with web transport over H2, maybe they would be okay with Qmux as well. Yeah, thank you.
Yaroslav Rosomachos, Zscaler. I think that this is moving into the right direction. So thank you very much for doing all this work over the years now. A couple of questions and comments that I would like to make. So first, I think it would be maybe further down the line beneficial to ask for additional column in the registry in terms of relevant frame types and transport parameters, where if they apply for Qmux or not. So that would allow authors of future extensions to decide if this is applicable there. Secondly, so right now you make TLS transport optional. So you require some transport, ideally TLS, but you open the door for potentially other transports. I think it adds unnecessary complexity. It feels to me that focusing on just TLS 1.3 over TCP in this work would make it more concrete, more specific, and potentially open some other options, such as maybe describing migration between UDP and TCP, or some kind of IP eyeballs v5 or whatever, when you can do both at the same time. And if UDP works, then you do that and do that very quickly and transparently. But if you insist that non-TLS use case is an important one, then perhaps worth considering signaling ALPN as outside of TLS, because that's an important property that's right now missing if you're not doing TLS. So I think you introduce some additional frame type to transfer transport parameters. So maybe ALPN belongs there if TLS is not available. So somebody already raised concerns about 16 kilobyte 16 kilobyte alignment with TLS record type, with TLS, sorry, record size. I'm not entirely sure that's the right number to choose from the performance reasons. And also one area that I think might appear is intermediaries. So you would have some kind of proxy or intermediary that would do Quic over UDP on one side and Qmux on the other side. So if instead of defaulting to 16 kilobyte, we would default to something closer to TCP segment size or typical Quic frame size on public internet, I think that would be beneficial for performance and many other use cases. So maybe it would be great to consider that. Also, I suspect that would reduce some of head of line blocking pains. And then finally, it would be great, I think, from the very beginning to add some additional text that this is really a fallback mechanism. If you can do Quic over UDP, do that, and outline more specifically all the downsides of QMux. Thank you.
Thank you very much.
Just going to quick chair interrupt there before you dive in. We have 8 people in the queue with 16 minutes for this session. So please keep your comments to 1 minute so we have some time at the end to wrap things up. But please go ahead, Guillaume.
Hi, I'll try to be quick. Guillaume, Microsoft. So to give some context, I'm very interested, or we are very interested in having Quic over RDMA, which is a bit different, and it's right in the spot where we are not doing Quic over TCP and TLS, but something different. And in that scenario, TLS over RDMA is not something that is trivial. We come directly with Quic that already implements a lot of cryptography-related concepts that would be able to fit there. And so, especially here, I guess it would fit in question 2. I think that there would be a lot of worth in at least optionally supporting full packets or a way of having cryptography coming from Quic and being able to make a stream secure. And building out of what Ted and Yaroslav have been saying, I guess a broader issue might be exactly what is QMux as it exists right now trying to support. Is it meant to support specifically the TLS over TCP fallback situation, or is it meant to support any kind of stream? And if the answer to that question is the second one, I think that we should be much broader, support encryption or support ways of having encryption so that we can support any stream. If the answer is the first one, there should be room for another text that's allowed to support those kind of situations. And then QMux as it exists can focus really on TCP and TLS.
Thank you very much. I think the 2 parts of your question is kind of related. And my understanding is that our charter says that that QMux is to be designed for bidirectional byte stream substrates, but with the default security provider being TLS. So I think I think the current QMux draft is going on the track of supporting any bidirectional byte stream that provides nothing other than that, but relying on, for example, Alpen for TLS because it's the default provider that we should assume to be there. So there's certainly questions about how we could optimize for other transports, but I think maybe we can do it step by step by first doing QMux as what our charter said, and then consider doing some more iterations to optimize for other things.
I just think you say that TLS is a default provider, which I agree, it would be the default situation. But it being the default doesn't make it always there, so you cannot assume it's there. It's just the most frequent case if it's default.
Right, I agree, and I think we could have another draft that extends QMux to do those kind of things. But yes, I think. Thank you for your comment.
Alan Frindell. So thank you for presenting this. Just to kind of run through the questions, keep it brief. Like I do think this draft is headed in the right direction. I do think sending frames and capsules on bidirectional byte sounds more appealing to me than dealing with packets. So I think that's good. I think the divergence question, like I would not be surprised after adoption, people go and fight about these kinds of things. Like I once was the editor of a document where I thought simplicity was better than saving things here and there. And every time the decision was made, people wanted, to have more complexity and a more efficient wire image. So I just wouldn't be surprised. And we also had the same discussion in web transport, and that's where we ended up. So you may not get the final answer to that question here today. And to some, on Quic V1V capsules, like I think it's not just about having a quick stack, it's also like, how well is it layered? And I maybe envy your position that you've had like mostly full control of your quick stack for a number of years, but like ours has kind of passed through several generations. And when we tried to write QMux using our quick stack, we were not as successful and since we were already along the way with transport, we've kind of gone that way. That being said, I'm not going to lay down on the road about saying it has to look one way or the other because I think things are similar enough. I did drop a comment in the chat about like length DOS attacks and stuff that we should just make sure that we're thinking about those as well. Thanks.
Thank you.
Alessandro Ghedini, Cloudflare. I agree. This is good, adding in the right direction. It's good that we went through the whole recharter, and I think this should be adopted at some point soon. As someone who will probably have to review code that implements this, I also agree on the fact of keeping the changes to the smallest amount of possible. So even if we might omit the offset of the stream because it's a little bit nicer, I think we should avoid doing those kind of changes, because then it avoids having all the if is qmax all over the place, and it becomes annoying. I'm somewhat conflicted about the frames versus packets, because as you pointed out, I imagine most Quic stacks expect packets to contain full frames, and having to implement the partial parsing seems like it would be a bit annoying. I don't know how complex that ends up being, but I also suspect I might be in the minority. So we can probably live with the frames rather than full packets.
Thank you.
So just a reminder, folks, please keep it to about 1 minute each, just so Kazuo might be able to respond as well.
Eric Kinnear, Apple, also a co-author here. I think a lot of these questions represent places where we're really saying, do we want to do something that is the most optimal or something that is the most pragmatic? And I think we're kind of proposing err on the side of pragmatic, with the idea that this is a thing that you do mostly as a fallback when you can't use UDP. I did have a follow-up question for Ted. Is the ossification concern that you're talking about more around API shape, or is it more around like what happens when we introduce yet another variant of an ACK frame and we want to be able to send that here as well? That would be wonderful. Thank you.
Marco Munizaga, Ethereum Foundation. Yeah, I just also want to highlight, I would like to use this for Unix sockets. So that's another byte stream, I guess. And then for question 3, preference for minimizing divergence. I mean, I think like I could imagine an application would want the offset field even in an ordered thing, ordered byte stream, because it might actually want to deliver the data out of order. There might be a use case there. And then just to note, I was the one who implemented this in QuickGo, and I'm not super familiar with the QuickGo code base, especially at that time. And I thought it was fairly straightforward.
Thank you.
Antonio Vicente, Cloudflare, but I think I want to speak about this one as an individual. I think that we need to take a step back in terms of what are we gaining and what we're actually losing by doing this implementation. It sounds like we're actually losing some things on the mock side by removing, say, support for things that are a best effort, not retransmittable. I was somewhat sad to actually see people like building a lot of things on top of like H2 or H3 without really like paying attention to HTTP semantics. It's actually like difficult if you actually have something that can only work on the newest and greatest version, which is one of the things, the reasons why I think I'm actually really excited to see QMOX as an alternative to actually give back semantics that are actually in Quic, but not in H2. I think this is an interesting effort. I don't know if it's actually exactly the full thing of what we actually want. Like to actually understand better like how mock is actually affected by some of these things. And yeah.
Thank you.
Martin Duke, Google. So the ALPN field says QMUX, correct? Not something else? And if so, how do I know that QMUX is delivering H3 or mock or whatever it's delivering?
If I recall correctly, we require that TLS ALPN is used to negotiate this. But similar to how it works with Quic and H3 now, the ALPN would be something like H3 over QMUX. equivalent. So that would be the binding of those two layers
All right.
together.
A note on the ossification thing. I think if we put a little bit of thought into that, there's like an initial throat clearing that happens in this with the transport parameters and whatnot. I think we incorporate some version negotiation stuff, we can make this extensible for new versions of Quic, whatnot. And then lastly, Ted and I are both mock chairs at one time or another. Mock is designed to leverage the advantages of the Quic transport protocol. It can run over TCP. That is understood to be worse. So I kind of respectfully disagree that this is changing the equation here. You can run it over QMUX. It will be worse because you don't get all the neat Quic stuff. Thanks.
Thank you.
Okay, cool. Thanks, folks, for being brief. We have drained the queue now. I do appreciate the inputs here. There's clearly more things to discuss. Obviously, this isn't a solution we can just pick up and publish quickly. The group doesn't have a good track record of doing that. But as chairs, we think we want to take a show of hands to get a few more numbers on this stuff to see maybe the quieter people, their opinions too. So we're going to open some poll questions and take a view. It's clearly there are more open questions for us to go away and discuss further and maybe interact with the mock working group. But I'd like people to focus on the two questions we want to ask today. And then Matt and I can confer briefly before maybe trying to come up with some next steps for this work. Give us a second. The first question we'd like to ask is purely just, have you read this draft or kind of earlier revisions of the same design under a different name? Let me start that poll. I'm going to close it in a second. Okay, I'm going to close it here. So for the record, that was a total participants of 94, 27 have read it, 28 have not read it, and 2 people don't know what they're doing. So that's a fair chunk of people. So it's kind of cool. So the second question we're going to ask here is, the literal question will be, is this draft a suitable starting point for adoption to satisfy the working group's new chartered work item? Maybe we could put up the charter text as well. If you go to one of the earlier slides, just to remind you folks what that item is. Click faster, Matt.
It's the second one from the beginning, I think.
Keep going.
Go on.
Okay. I'm starting the poll, which is just blocked. No, it's still up there. Okay. Going to close it in a second in case it's still fumbling. Nope. Okay, closing that out. For the record, we had 95 participants this time, one more. We had 29 yes, this is a draft that's suitable for starting point for adoption. 4 no, and 21 no opinion. For any of the folks that said no, is there anything you would like to bring to the mic that hasn't already been covered about why you don't think this is a suitable document? Or maybe you would like to bring this to the list afterwards. I see Ted getting up.
Very quickly, I think the aim of the document to bring the Quic contract, API contract to the other substrates isn't met because the negotiation is being excluded by the draft. The transport negotiation, the level of exclusion there, I think, means that this needs more work before it's ready to go into the bin to fulfill this charter text. Personal opinion.
Okay, thank you, Ted. Christian?
Basically, same opinion as Ted. We need to have the same negotiation as in Quic. We need to be able to negotiate that we have extra frames. We need to be able to negotiate things like ACK and things like that. I mean, all Quic frames should be legit unless there is, if they are negotiated. So we need to have the negotiation.
Christian and Ted, is it your opinion that the current document cannot be transmorphed to do that, and it needs fundamental rewriting, or do you think that's something that could be worked on with the adopted document?
It can probably be worked on. There is a beginning of negotiation in the beginning of the TLS stream. That negotiation should be aligned with the transport parameter negotiation that we have in Quic and the version number 2.
Speaking as a chair who's often said, adopt anything you like. We can burn it down to the ground on version 0.0 of the working group draft. It is obviously possible to take this and turn it into an ode to pansies. It's okay. They're a beautiful flower. But I think that starting from where we are, we should say something different about the negotiation capabilities before we adopt. But the rough I am in it, I can count.
So if there was less said about negotiation, would that make you happier? Okay. Yeah, he was nodding for the AI. And Marco.
Okay, we're at time. I think we've got some really strong signals there on how to proceed. Matt and I will confer offline. We'll speak with our responsible AD and the authors and look out on the list for updates on this. And thank you, Kazuo. Next up, we have our As Time Permits bucket, and we have some time permits. So, Marco.
Does this thing go down? No. I was the note taker. If someone else could fill in, that would be great. Cool. So, is there a way to bring this down? Thank you. All right. First, my apologies to Martin. I should have put your name here. I'm sorry. Martin is a co-author on this draft. Cool. So, I'm proposing a new frame called new preferred address, and this addresses this would allow a server to request a connection migration mid-connection. So to recap, clients can migrate to any address at any point. A server can only migrate to a new address once and at the beginning, and there's no way for a server to migrate to a new address later on in the connection. In peer-to-peer environments, who's a server and who's a client is somewhat arbitrary. I want to introduce a new preferred address frame that would allow the server to request that the client migrate to a new address. And this is treated almost the same as, or basically the same as, a connection migration due to the preferred address transport parameter. So for background, the preferred address transport parameter is a transport parameter that allows servers to request that the client migrate at the beginning of the connection, but it only works once. I went through the archive to pull up past discussions around this to try to help bring some context around here. And apologies, these are not very big slides, so there's a lot of context missing. But the overall sentiment seemed that there was interest in this, but also a very understandable desire to keep scope down and save this for a future work. So that's what I'm here. I'm here to do that future extension that we talked about all those years ago. It's a small extension. It piggybacks on the existing logic of the preferred address transport parameter. And yeah, it gives us this mid-connection migration ability. So here's the frame. It looks very similar to the preferred address transport parameter, with the exception of not including things that you can pass in other frames. So if I tell you this problem, you can probably tell me a couple alternatives. We could imagine doing this at the application layer. So we close the connection, ask the client to reconnect to us to our new address. And we do this via some application message. And we possibly do this in 0TT. This works, but I think we can do better. So the downside with this approach is that it requires the application to serialize. Hang on. It requires the application to serialize its current connection stream state. And with connection migration, we can keep the existing connection stream state and make very little application changes to support this migration. The other alternative is using the multipath extension more quick. I think this would work. Somewhere in the application layer, you would give the client the server's new address, and it would just open a new path and eventually migrate to that. Yes, Mira, please correct me. Okay. Yeah, so the main downside with that is it's much larger thing for this if you only cared about migrating the connection and not multipath. Yeah, so I try to keep this short because I wanted to save a lot of time here for questions. So my questions are there any new security considerations from allowing a dynamically chosen preferred address? Generally, I think these are the same as the preferred address transport parameter. I think there's a new thundering herd consideration. You can imagine the server collecting clients and trying to migrate them all to a target address. But maybe there's something else I'm missing. And then is there interest in this room for this extension? So I have a use case. I'm happy to talk about it, but I'm curious if other folks have a use case that would be fulfilled by this. And yeah, just general questions.
Yeah, that was exactly my question. I think we left this out because we left everything out where we don't have a concrete use case. And you said something about peer-to-peer, but can you say a little bit more about the
happy
use
to.
case?
So give me 1 second. Yeah, so for the peer-to-peer network, you can imagine a peer is connected to a mask proxy for various reasons, and it wants to migrate to another mask proxy, and it wants to be able to migrate all its connections, not just the ones it happens to be a client in. Does that make sense? So right now, as it exists today, let's say random chance, if you're a client or server, you'd only bring 50% of your clients, and then just, yeah, we could do better.
Christian.
Well, first, I should say that there is no particular reason to have this new address frame tied to connection migration rather than multipath. It's completely orthogonal. If you have only negotiated that you can do connection migration, you do connection migration. If you have negotiated that you can do multipath, you do the multipath thing, which with a new address, you open a new path and it gets migrated there using a make before break kind of protocol. So there is no reason to have this discussion of migration versus multipath in your draft. It's just irrelevant.
Sorry, can you repeat that?
That frame would work equally well if you can only do migration and if you can do multipath.
Mhm.
There is no reason to have discussion of multipath versus migration in your draft.
Yes, I don't think in the draft there's any discussion around multipath.
Okay.
I'm just mentioning it here as an alternative where you can imagine if your quick stack used multipath, you wouldn't need this frame.
That is not true.
Okay, great. That's helpful for me to know. Thank you.
Now, the other thing on your frame is that you start from a frame that was sent during the handshake, and you have two address families present in the frame. I think that was a constraint of the end frame, but basically, if you are going to do that inside the connection later on, you should just pick one. And if you want to have an IPv6 address and an IPv4 address, you just send two frames. There is no reason to do that, okay? You have to specify what the sequence number means.
Yes,
If
that's specified.
does the sequence number mean that only that address can be used, or does it mean that it's another address among the many that I can use?
The sequence number specifies if you get multiple of these, you should only use the one with the largest sequence number.
But that's not, that's different. That's unrelated. That's a
We're
policy
almost at
decision.
time, Christian, so maybe we can,
Okay,
yeah.
so there is a lot of things to be decided there. But the big issue, the reason we have not done it yet, is not because we have no idea of doing that. I mean, there have been variations of that frame presented for at least 4 years ago. The big reason is that you have to discuss the security issues. And there are huge security issues, and the reason we did not do it.
Yep.
Yeah, thank you.
Eric Kinnear, Apple. I'd second some of what Christian's saying there. There's some spelling things we can work in here. Do you give people a new connection ID to use with that new path? Stuff like that. So we can work through some of that. We've talked for a while about having a please migrate thing. I think it would be super useful to say, hey, this is an address, another place you can find me, versus, hey, it would be nice if you moved here, versus like a, hey, you got to move right now. I think there's different use cases have different needs for that. So we can talk about that. So ignoring spelling stuff, I think there is a use here. I like digging up some of what we talked about in the past. I think the Zurich interim had some other discussion that you might want to look at for where we started digging into just how much scope we were adding and decided not to.
Cool.
Tommy Pauly, Apple, thank you for doing this. I think this is a good time to do this. I think it's worthwhile doing. I think the peer-to-peer and proxying cases are very compelling. Christian's points were all very good. I think you could have multiple frame types for different families, maybe different sequence numbers for different address families, but like those are things that can be worked out.
Mhm.
It's right that the security issues need dealing with, but we can do that. That seems like it's a tractable thing. So
yeah,
I think we should do this work here.
Cool. We'll continue the discussion on the list then.
Yeah.
Thank you.
All right, and finally, we've got Rich to talk about the. Marco, you brought the clicker.
Next slide, please. Hi, my name's Rich. I've never really been to a quick session before, so you're in luck. Yuan Jinghao, like many of our colleagues from China, had visa problems, so I helped work the draft and I'm presenting. Some of the background, right? There's a real need to get congestion control information so that in future connections we can do careful resume. The best time to get that stuff is when you're, from the guy on the other side, entity on the other side, collecting samples, and then send it to the client, send it to the peer so that they can send it back next time they connect. Clients, for scaling purposes, clients usually have a finite number of servers they talk to, or at least a manageable number compared to the address space that they've got available to them. Servers don't. So what we need is a mechanism for the one side, the server side, to send data to the client so that next time it connects, it can send, here's what your network was last time I spoke to you. And that's, I didn't draw this diagram, and I'm not fully sure I understand all the piece parts, but in view of time, it doesn't matter. So what we're doing is we propose to add 2 new quick frames. One is the connection thing that allows the sender to say, here's the congestion information that I have. It's integrity protected with a little twist. I'll talk about it in 2 minutes, I guess. And then the other frame says, send me any congestion information you have. The congestion data is in particular not encrypted. It's integrity protected, or parts of it are, so that the client can then look at the data, make sure there's nothing, whatever the word is, mean about it or evil about it. It can also pull out that data and send it to its own network stack, so that its side can also do benefit from the early knowledge of the congestion data. There's a support congestion data parameter now, or is it proposed? If we can wait till the end, because it'll be short. Yeah. Consume means if the person who sends this in the congestion says, I'm interested in getting congestion data that I may use, there is the ability to cache it, saying, I'm going to say, you can send me congestion data, I'll hold on to it. And then there's the third option, it's a bitmap that says, give me the values that you might have gotten earlier on. The data that's actually sent in the frames is a TLV, right? Tag like value. We've defined, I don't know how many, we've defined 30 types, 24 types of various things, timestamp, the path tuple that we connected to, what the slow start status is, the round trip time, all of the things that a typical congestion control block facility, subsystem, whatever you want to call it, might want to see. Tag length value, all of those are sent in the clear, except over the quick encryption scheme. The congestion data frame has 2 blocks of those. One, 2 types. First one, the congestion data frame, a whole bunch of statistics, and then an integrity identifier that is deliberately unspecified so that it's known only to the server or the sender of the congestion data. And then there can be unprotected attacks. You can look at it. The intent of the integrity tag is if you tell your server or whoever's on the peer on the other side, you give me this congestion data and I will send it back to you. You want to make sure that what you get back is untampered, right? So that you're not pretending to be better than you are. But it's also in the clear. Interesting security requirements there. And then there's unprotected data. Depending on the trust model and the area in which you're working, you may have all completely, for example, if you're inside a known data center and a known enterprise exchanging microservice data over Quic, it may be all unprotected. It may be all the integrity tag may not exist. We tried to provide a flexible security mechanism. The data frame is not retransmittable. You send it once. If the congestion was such that it didn't get through, oh well. The data frame can be sent at any point, and it modifies updates the connection, and so on. If the endpoint sets the cache flag, the peer should put its statistics into this protected field, calculate an integrity, and send it along. If the endpoint sets the consider flag, again, consider flag, the peer should put the statistics, any other statistics it's willing to send, also in the unprotected send. Receivers can parse the data, use it, save it for later on retrieval by the peer when it asks for it, and use the data in its own network stack. Sorry, the recall frame looks the same kind of thing. Doesn't matter much. Okay. Other approaches. There is an address validation token, which the server or the receiver can send back to the peer or the client. That's completely opaque to the client. You have no idea what's in it. It could be a super cookie or whatever the bad things of the day are. The congestion data by design is visible to the client, usable by the application layer, usable by either side. in its network stack and so on. Also, if you don't understand particular things, just don't send the congestion data back, and then you presumably lose some of the initial slow start or speed up throughput that is available. Similar privacy implications, you discard it when you think there's other mechanisms that have been cleared that are doing tracking. Next steps, we probably need to make some changes, right? First draft. This is used in production in the TikTok network. And we're seeking working group adoption, but we probably would like to do or have to do another version of the draft first. And with that, open the floor.
Very briefly, folks, we have 40 seconds and 4 people, so you do the maths.
Okay, first of all, this reminds me of the discussion of the BDP frame that we had a couple of years ago and that we decided to not move forward with. As you said, for restoring these parameters, you can put them in the token or the session ticket, and you could argue that it's an advantage that it's opaque to the client. Because the client might be running a very different congestion controller than the server. And from my experience with different Quic stacks, we all have various tweaks to the congestion controller. So it's I'm doubtful that they are actually comparable. Also, the path might not be symmetric.
Yep. Lars, I get Mozilla. It's not clear to me that this has the exact same security considerations as the token. I want more words that reassure me that this is the case.
Sure.
Only got 10 seconds. WAT. No. So my biggest question here is actually, how do I know where in the offset of the datagram or the packet I should start reading this information, right? Like I'm assuming this is embedded within, like it's embeddable within a packet, like any set of frames.
Right.
You've just got like high entropy mir, and then you've got, hey, this like scanning through that is unlikely to work. Can you say a couple of words about that?
No. Partially because I don't know, and no, actually it's an admission. We need to document what the best way to do that is.
I think there are ways to do it, but you need to be very careful about it.
Yes.
Okay, I'm gonna end things there. Thanks very much, Rich. There's clearly some interest from folks on talking about this topic with the authors, both for this draft and Marco's new address. I encourage people to meet up after here and discuss some things and maybe take any evolution of the design to the list and really solicit the ideas a bit more, I think.
Sure, absolutely. And thanks for in the short time people had, I appreciate the questions. They point out things we need to improve in the doc.
And thanks for being very brief. Thanks, Rich. Yeah, we are out of time for Lars to do his more quick spiel, but if you want to congregate around him, if you weren't able to attend that session, please do. Thank you all, and wish you a nice Thursday evening, and we'll see you on the list.